This is part 5 of section 6.2. We want to solve the triangle that has an angle B that is 32 degrees, side B 50, side C 60. We don't know it. A, B is 50, and C is 60. Okay, since we have part of our C, let's find angle C first. So sine of C over 60 is equal to sine of 32 degrees over 50. So we get C is equal to sine inverse of 60 sine of 32 degrees divided by 50. And you get that your C value is approximately 39.5 degrees. And then we should look for the other possibility, 180 minus 39.5, and see if this is possible. And if you get that, you get 140.5 degrees. And if we add the 32 degrees to that, we are still less than 180. So we have two answers here. We have two triangles, okay? So for this one, our C value is 39.5 degrees. So our A value is 180 minus 32 minus 39.5, which will give us 108.5. Now we use this to find A. A over sine of 108.5 degrees is equal to 50 over sine of 32. And then we find that our A value here is approximately 89.5. So that's one triangle solved. Let's do the other one. C equals 140.5. And then we don't know our A value. Our B is 50 and our C is 60. We can find A by doing 180 minus 32 minus 140.5, and you get that your A value must be 7.5 degrees. Now to find length A, I have A over sine of 7.5. And that's going to equal 50 over sine of 32 degrees. Solve that for A, and you'll find that your A value is approximately 12.3. So in this case, since it gave us two triangles, we needed to solve for both of them. And as soon as we got two values for C, that meant we had two separate problems going on. Now, there's one more topic here, and that's finding the area of an SAS triangle. Okay, if we have any triangle ABC, the area of that triangle is given by this formula. All you need to know is two sides and the angle between. Half of the two sides multiplied together times sine of the other angle. So here it's BC sine A, AB sine C, CA sine B. Okay, and they're all equivalent. So let's look at this problem. We want to find the exact value of the area of the triangle with angle B of 60 degrees A is 12, C is 7. So the area is 1/2 times your two sides times sine of the angle you're given. Okay, so what do I have here? That's 6 times 7, which is 42, times sine of 60 degrees is square root 3 over 2. So multiplying that together, you get 21 square roots of 3. And that will be the precise area of that triangle. Okay, now let's find the area of the triangle where our angle is 146.7 degrees. Side B is 16.7 feet, and side C is 18 feet. And we went around to the nearest tenth. Okay, so the area will equal 1/2 times the two sides we have, times sine of the angle we have. Okay? And that is 150.3 times sine of 146.7 degrees. Plugging that into your calculator and rounding to the nearest tenth, you get approximately 82.5. Here we're given our units, so feet squared. Square units because it's an area. Okay? So this one's a little bit different. We're given an area and two sides, and we want to find the angle or angles between the two sides. Okay? So what I have is our area is equal to 1/2 times the two sides that we have, 5 square root 2 and 6, and then multiply by sine of that angle that we're looking for. In this case, it's theta, okay? If they were labeled A, B, and C, the angle we were looking for would be C. So multiplying all of this, I got 15 is equal to 15 square roots of 2 sine of theta. And solving this for sine theta, I get 15 over 15 square roots of 2. It's 1 over square root of 2, which is the same thing as square root 2 over 2. So theta, one possibility, is sine inverse of square root 2 over 2, which is 45 degrees. Okay. And then the other possibility would be 180 minus 45 degrees, which gives you 135 degrees. So this information could come from two different triangles.